Hey everyone, welcome to 197 Concepts. So in this video, I'm going to discuss with you how to make a printed circuit board uh, in the software itself. So you might be familiar with it when you're designing a printed circuit board. You must have to get a circuit print so that you can take that print and copy that exact circuit onto the copper board for the etching process and all. So in this video, I'm going to discuss with you how you are going to create that print, which is called as ready to print virtually. Okay. So for that, I'm selecting the circuit, or yeah, I'm selecting the circuit of 7805, right? So you will be familiar with this. This is called as the voltage regulator. Okay, so voltage regulator. Before going for the procedure, you must know your circuit. Okay, so the very first thing that you need to know is what is a voltage regulator. So this regulator is nothing but a device that gives you a constant voltage. Okay, for example, if I set this voltage regulator for 5 volts throughout its time period. So if it is 0 seconds or 1 second or 2 seconds or 3 seconds or say like 100th second, it should give only 5 volts of output. Okay, it should not fluctuate like 6 volts, 7 volts, then 4 volts, then 2 volts, then 5 volts. It should not fluctuate. So it should give a constant 5 volts whatever you're giving as the input. So if you are varying the input also, if you are varying the input within its range, it should give 5 volts. Okay, that is called as a voltage regulator. For that, first of all, we need a full wave rectifier, and full wave rectifier is used for converting your alternating current into direct current. Of course, that is not a pure direct current, and to convert that non im or to convert that impure direct current, we are using the regulator. Okay, so let us know the circuit first. So the circuit definitely comes with the transformer like this. Of course, it's a step down transformer. I'm just drawing it like this, or else let us do it properly. Where's the eraser? Let us do it properly, okay? So I'm just, yeah. Oh, it's a step down, right? So it should have more windings, and it should have less windings. And for the input, definitely I'm going to give here some voltage. Like this is definitely AC source. I've written that V, okay, and this is definitely 220 volts with 50 hertz. That's the input we get at our home outlets. Okay, so this is a transformer. Then we need a bridge diode. So the diodes bridge. So my drawing is not good as it's computer. Yeah, that's a bridge, and here I'm going to connect this. This completes the transformer, yeah, full wave rectifier. And before giving to the load, I am going to connect it to the 7805 IC. This is grounded, and this is the out, not the output, the negative terminal. This point will be grounded, and here I have a resistor, that's R, which is also grounded, and I have a capacitor to filter out, okay, which is also grounded. And here I will be connecting a voltmeter, DC voltmeter, in order to see the readings. Okay, so this is the main circuit. This what this is going to do is this bridge is going to convert the alternating current into a direct current, and the 7805 is going to make it a pure direct current. So what's the difference? Let me show you in the graph. So if we just if we just keep it like this is the alternating current that you get at the transformer. And so yeah, the graphs are not evenly spaced out. Just be with me. And this is the output that we get after the rectifier, after the bridge diode. And finally, when it is passed through the 7805, we get a straight line of 5 volts. Okay, this should be the output, and this has to be converted into a ready to print format for our PCB layout. Okay, for designing our PCB. And that's the main circuit. And for this conversion, I'm going to use our commonly used software, that's the Proteus. And here we are going for the new project. Yeah, and selecting your path, select folder, project name 7805. Next. No need to change any settings, just click on finish. So this is the starting of the project. So 7805, I have I have made a project with the name of 7805 in the Proteus. Now we need the components. So you are familiar with the components. The first thing that we need is a transformer. Transformer. I typed the keyword wrong. So we need two poles and two primary, two secondary. So this is the transformer. Then I need a bridge diode. Instead of going for the bridge diode, I'm going to use the diodes itself. Okay. So I'm going to create my own bridge. I just need a diode. Diode. I have the PCB preview. So diode is there. Then the next thing that I need is a capacitor. Yeah, be careful when using the PCB preview. You have to keep in mind that your device or your Proteus or the device that you are selecting is already having a PCB preview. If you're not having, for example, like what we say for this one, you have to create your own PCB. Okay, you have to create your own footprint. So I'm going for this one. I'm having the footprint. I'm already having the footprint. So I'm going with this capacitor. Then in the same manner, I need a resistor. It's same for everything. See, I have selected a generic resistor symbol and I have the footprint of it also. If I select some other resistor, of course it's a resistor. Which one can I show you? This is a variable resistor. This is also a variable resistor. Let's go with this. If you select something like this is a general resistor but it's not having a PCB preview, then you have to assign your own PCB preview, or you can call it as a footprint for this resistor. So instead of doing that, I'm just going for the basic one. Yeah, these are the things. And yes, of course we need the power supply, which is nothing but our V sign. Okay, so yeah, V sign, click on OK. Now I'm placing the components one by one. So the very first thing is the V sign, then uh, transformer. Okay, I will go for the diodes at the last. Our capacitor, I'm going to rotate in clockwise direction, and the resistor also, I'm going to place it and rotate it in the clockwise direction. The very main thing we forgot, that's the 7805. Okay, don't go for 7806. Okay, you have the 7806. It looks similar. The output varies. Okay, so 7805 will give you a maximum voltage of 5 volts, whereas 7805 will give you for 5 volts, whereas 7806 will give you uh, a voltage of 6 volts. Okay, so 7805. This one is placed here, and I need to do the connections according to the circuit. Okay, so let's just go and connect this first, then this one, in order to keep it in the center like this, and this block, and finally the ground. Yeah, we need a ground, terminal mode ground, and I'm going to select this ground. Okay, of course we need an oscilloscope also. Yeah, a DC voltmeter also. So I'm placing a DC voltmeter here and connecting it to the circuit. Along with that, I need an oscilloscope to see the three outputs. So I'm placing the oscilloscope here, and let's do these connections first. These are the easiest one. Just go there. Yeah, that's the thing. For setting this setting up this V sign, I'm going to amplitude of 220 volts, whereas the frequency should be 50 hertz. Okay. Now we need four diodes. So diode 1, diode 2, diode 3, diode 4. Keep in mind the diode 3 and diode 4 should be facing downwards. Yeah, for that you can check the bridge. This is the bridge, right? And keep in mind the directions should be in this manner itself. If you change the directions, they are going to behave differently. So I'm going to rotate it anti-clockwise, and now I'm going to connect all these four diodes like this. Okay, now the hardest part is to connect this with the transformer and the output and the 7805 regulator. Okay, for that you have to observe the circuit. See, if I consider if I consider this as D1, this as D2, this as D3, and this one as D4, you have to keep in mind the directions of it. Okay, so first of all, observe the transformer connections. The transformer connection, the positive terminal has to be connected, the upper side has to be connected between D4 and D1. Okay, so that the connection is in this manner. See, this is a diode and this is a diode. It should be connected like this. You have to connect it somewhere here. Okay, for that you are going to observe such connection here at this point. So simply I'm just going to connect this at this point. I believe that's it. Yeah, and I'm going to take the output from D1 between D1 and D3. So this is going to be connected to U1, right? Now the ground part. The ground part or the ground part has to be connected between D4 and D2. Okay. So between D4 and D2. So this is going to be connected to ground, right? So D2 and D4. Yeah, and D2 and D3 must be connected to the transformer, the middle point between D2 and D3. So D2 and D3. So this is the middle point. This has to be connected to the transformer. Okay, so this is the overall circuit connections. Now, don't connect this directly to the ground. Like some people, what they do is they will just connect the transformer to this part and they will connect it to the ground like this. It will not give you a proper output. Let us check it once. So A, I'm going to connect it for the input supply, and B, I'm going to check it the rectified output, and C, I'm going to check the regulated output. Okay, now I'm just going to run the simulation. Yeah, I just need to set these values. Oh yeah, there's a fatal simulation error, so I believe it's because of this connection. Okay, so for that what we have to do is we have to just change the connections. That should go like this, and this should go like this. Now let's run the simulation. Yeah, that's much better. but I need to reduce the value of this because 220 I'm not able to see this in the uh, graph, and what I'm going to do is I'm going to increase the frequency for 100. Okay, so this is the output, this is the input that I'm giving to the transformer, and this is the output from the rectified input, not rectified input, from the diodes, that is the bridge, and finally this is the regulated output. So if you observe here, you're not getting a steady output, like you're not getting a steady 5 volts. Let me off this one, I don't need this. Okay, if you observe here, so this is the regulated, this is the input to the transformer, this is the output from the bridge diode, and this is the rectified output. So this rectified output is, it's a little bit fluctuating, and if you observe that uh, in the ammeter, you're getting 0 volts because we are missing something. Of course, we are getting a rectified output, we are not getting it regulated. So we have to do some changes here, like changing this from nano to micro, 1 microfarads, and 10 kilo ohms is enough. Let me see this. Now we are getting a 5 volts, but the capacitor, it's discharging very fastly. Okay, we are getting a rectified output, but clearly it's not a pure wave. Okay, so for that I think it will be much better if I increase this value. So yeah, that's not the point. So this is enough. It should draw more current more aggressively. Let's go with 100. Let's see what's happened. It's much better. Yeah, you can say it. Of course, the discharge is much delayed when charging, but you can say the output is also very much stable. Okay, when you compare it with 10K, let's try this with 10K once. Yeah, there are some ripples. There are very minute. There are very minute. What we say? Disturbances in the regularity. So we can increase this. Let us try with this with 50K. Yeah, 50 is also very smooth. It's very steady. Let us say with 20. Even 20 is good, no doubt. Okay. So finally, what I'm trying to say is this is our final output at the circuit level, at the schematic capture. Okay, so we are giving an alternating current as input, and we are getting a pulsating DC. Finally we are getting a regulated uh, DC, direct current. Now we need to convert this into a layout so that we can take the print onto the uh, copper board. For that, we need to do some necessary changes. See, the transformer, we are going to install this from the outside of the board, not within the board. So for that purpose, we don't need this transformer to be embedded into into the ready to print. So as the V sign, so as the this voltmeter and the oscilloscope. But we need points. We need certain points to get the outside, to get the voltages or signals from V1 sign to measure what is the input we are giving, and from this point to check whether we are getting a rectified output or not, and then from this point to get a regulated output in order to check in the oscilloscope. At the same time, we need 2 points for the voltmeter also, and one particular point for ground. What I'm going to do is I'm just going here and I'm going to select headers, and in the headers I'm going one for 3 pin, one for 2 pin, and one for 1 pin. Okay, so this is 1 pin, this is 2 pin, and this is 3 pin. That's it, and I'm clicking on OK. So what is the purpose of 1 pin? Just I'm going to tell. Okay, let's keep this circuit as it is. I am just going to copy this circuit, block copy, and I'm going to paste this right here. Okay, now in this part I don't need this one, I don't need this one, I don't need the ground, I don't need the transformer, and V1 also, because V sign you are going to give it from the wall socket. So this is the only part that I need, and this is the only part that I need, and I'm going to modify our circuit. I'm keeping it side by side so you can get a clear idea. So yeah, this is the only one pin one. So just component mode, I'm selecting it here. I'm rotating it clockwise, so this will be a direct connection. I need to move the circuit a little bit upper so I get much space at the below. Yeah, that's it. That's it. Now, what I'm going to do is I'm simply dragging this here to make it a ground contact. Okay, and here to get the to give the input from the transformer. Oh, so yeah, I need two pin. Yes, definitely I need a two pin here. I'm rotating it by 180 degrees, and one input. One input. Observe here, one input has to go between D4 and D1. So the one input has to go from here to this part, and one input should go between D3 and D4. So one input should go, this will cause some trouble because two and one and two. So yeah, one, let's get it to the top, and two, let's get it to the bottom, right? That's it. Now I need another jumper for J3 for checking the output using multimeter. That's why I'm placing this. And finally, I need one point to check all the three signals and connect it to the oscilloscope. For that, I'm using a 3-point header. From this point one, and from here one connection, and finally, okay, that should you should get one from the transformer. So for that, you can use just two pin header, because one you will be getting from the, what we say, transformer itself. So there one, and there, that's the one. This is completely unnecessary. It's just your wish in order to make it future proof. That's it. Okay. Now what I'm going to do is I'm going to create a PCB layout for this particular part. Okay. Keep in mind we need D5, D6, D7, D8, J2, J4, J3, J1, and U2, C2, and R2. So from here I'm going to this PCB layout. Okay. Immediately after going into the PCB layout, what I'm going to do is I'm going to right click here in the empty space. Then I'm selecting this place and I'm selecting the box option. Definitely I get the pen immediately after selecting the box option, and at the layer selector I'm going to select the board edge so that I can get a board like this. Now to verify this, just go for 3D viewer and you will get a board. So initially if you have no board like this, like if I delete the object and go for 3D visualizer, you won't be having anything here to see. Okay, so for that I am going to just draw a board here. Now see it, I got the board. So now what I'm going to do is I'm going into the component mode and placing the components one by one. So what I have is C1, C2, D1, D2, D3, D4, D5. Yeah, after D4 we can use diode D1. Okay, so yeah, if you keep D1 and D2 and D3 and D4, you will get a problem, because if you observe here, the J2 is connected with D4, D8, D6, and D7. Oh, sorry, D5, D7, D5, D6, D7, D8. But the transformer is connected to D1, D2, D3, D4. So there is no direct connection between J2 and D1, D1, D2, D3, D4. Now, if you try to connect this jumper with D1, D2, D3, D4 in the PCB layout, it won't accept. Okay, I will show you that. Like randomly, just let me place J2. Is that J2? Yeah, J2. Now what I'm going to do is I'm going to place a jumper J2 here. So this is showing an arrow mark which shows that there is a connection between J2 and D5. But there is no such connection between D1, D2, D3 and D5 with J2. Oh, sorry, D4 with J2. Okay, so that's the main purpose. What you have to do is you have to use this circuit and these components itself. You might think that if you can use D1 with J2. No, that's not possible. The software is not going to accept that. So simply these are just wait. I'm going to just delete those. Okay. Now I need J1 is complete. J2 I have pasted. The J2 I have placed it. That's why you can see here the list has been updated. J2 is missing there. I'm going to place J1 and at the same time J3 and J4. Okay. Now I need resistor R2 and capacitor C2 like this. So with the 1 microfarad did we get the output? Yeah, I have to delete this. Block delete. Yes, we got the output for 1 microfarad. I'm just going to undo it. PCB layout. And yeah, C2 I have placed it. Now, what I need to place are D6, D7, and D8. Okay, yeah, U2. Okay, now what you have to do is try to keep this circuit similar to this circuit. Okay, what you have designed in schematic capture, try to keep the circuit in the same manner. So starting with J2, what I'm going to do is first I'm going to place J2. So for that I'm going to go in selection mode, and first I'm going to place J2, then D5 at the top, D5 at the top, yeah, it should be in the same way, D6 at the bottom, right? D7, it should be rotated in a vertical position, but the cathode has to be in the upside direction, so anti-clockwise. And yeah, there you go. That's D7, and no, that's flipping anti-clockwise. And yeah, there's our D8. Okay, now after placing these from D7, you are I'm connecting this to the 7805 and to the capacitor C2. Better if I rotate this clockwise, so I will get better connections. And R2 rotated clockwise. Okay, now J3 is, what is J3 for? J3 is for checking the output. So it's for what we say multimeter. So drag the object. I'm going to place it here. Okay, and J4 is for checking the oscillator output. So I'm going to place it here, and finally this is for the ground. You can place it like this. Now what you have to do is observe these lines. There should be no overlappings. So this arrow tells that after this device is connected to this device somewhere, and D8 is connected with D7, and J2 is connected with D7. So those arrows tells those things, and the green lines tells us the path from J2. The first terminal of J2 is connected to the cathode of, sorry, anode of D5. So that the lines will tell us. You cannot delete these lines. Okay, keep in mind you cannot delete these lines. You can just, they are just for the resemblance. When you connect those two terminals, that line is going to uh, that line is going to be out of your sight. Okay, so for that, for placing the roots, what I'm going to do is I'm going in the track mode. Okay, immediately you will be getting an option of bottom copper or top copper. So bottom copper, if you observe here, see, you have placed the components, all the components here. So bottom copper means you are going to get the roots at the bottom side. Here you are going to get the all the copper tracks here, and top copper means you are going to connect all the components from the top side itself. So I'm going for top side, and if you observe here, all the components are placed in this manner. These, there has to be no overlappings like this one here. If you try to use only single layer, and if you try to connect this terminal 2 of J2 with the cathode of D6, there is a connection between D8 and D6 of both the anodes of both the diodes. So this path is going to overlap with between J2 and D6. And if you are using a single layer, so that's going to come here, this one, this terminal and this terminal and these two, that path is going to collide with each other, and that might short circuit your whole circuit. For that, keep in mind, you should never overlap the lines on a single layer. Now that's the main thing. In order to prevent that part, like the overlapping part, you have to properly arrange these elements and try to make them rotate. Not make them rotate, you have to rotate them. Like if I would do this, there's a clear path. Okay, so this will save me from overlapping. And this is a little bit down. You can move this much up. So yeah, or else let it be there. It has formed the lines. And now if I rotate this clockwise, it is much clear. If I rotate this anti-clockwise, like this was the previous position, if I rotate this anti-clockwise, there is going to be a little bit of problem here for the jumper. Okay, so J2 is going to connect here and J1 is going to connect here. This will cause me a little bit of problem. Also, J2 is connected with J3's first terminal. So that will cause me a little bit of problem here. Not this one, this one. Yeah. Okay. For that, what I'm going to do is I'm just going to rotate it in 180 degrees, and I'm going to keep it in this manner. In the same way, the J4 is, I'm going to rotate it, and yeah, if I keep it in this way, is it going to reduce me the overlaps? Definitely, this is going to reduce me the overlaps. Now, what I'm going to do is I'm just going to change the labels. So double click on this, and instead of J2, what I'm going to do is I'm going to type here input, or else just two words in, and I'm going to change this label from here to here so that it is clearly visible. Can I rotate this? Yeah, I can rotate this for 0 degrees, and I can place it here. This is the in pin. So all the diodes are good. This one is good. You can name this as 7805, and you can place it like this here so that it's properly aligned. And J1, instead of J1, what I'm going to type here is GND, ground. Okay, and I'm going to move this label from there to the bottom. Then what I have here is J3. This can be voltmeter. You can write voltmeter. That will be very lengthy. No problem. Yeah, voltmeter. And this waveforms. Waveforms. Yeah, waveforms. That's it. Okay. Or else you can change it. That's very long. OSC, oscilloscope, and instead of voltmeter, you can keep this as volts. Volts. Okay. Now, if you observe the 3D visualizer, you can see the markings here. C2 ground, R2, that is volts, oscilloscope. Okay. Carry the. Video record कर दो. So this is the complete circuit. This is the complete components that we have placed. Now we have to just do the wiring of it. Okay. So for the wiring, I have selected here the path mode and I'm selected the top copper. Now I'm going to start from this point. The very first point that I'm going to connect is the in terminal with the cathode. This. Okay. So that's completely depends on you how you are gonna wire. I'm going to wire it a little bit smoothly to keep the resistance low. Okay. So if there are more bends or more aggressive bends, you will get more resistance. So in order to reduce the resistance, you have to keep it a little bit more less angular. Okay. So yeah, it's all about left clicks and just one left click and then one left click will lock the path and finally you will get it to place here. So yeah, here, here and here. And in the same manner, just with the left clicks, you have designed this part. Okay. Now there is a connection of ground. Okay. So if you observe here, the D6 is connected to the ground, but not the transformer part. Okay, it's connected to D7 and it's going to be here. Going back to the jumper 2. And if you observe here, it is true. So this pin 2 of the jumper J2 is connected to the cathode of D6. And if you observe here, the C2 line is connected to the A anode of D6. Okay, so it's a straight line. So being a straight line, it seems that the D6, the cathode of D6 is a junction point for the pin 2 and the capacitor. Okay, but that's not true. You have to keep in mind, you have to be very clear of this terminals. So yeah, if this is connected to ground, what I'm going to do is simply I'm just going to connect from here. I'm just giving a left click and I'm directly connecting it to the ground like this. Okay, so that line has disappeared and we have only one line. This is this part. So simple, I'm just going to do this, the straight paths. First of all, yeah, this one, I'm going to place it like this. It can go a little bit further like this. And yeah, you can just create a junction from here so that this thing places this. So you have just made a node here. Okay, and the next part, so the next part will be connecting to the grounds. So yeah, that one goes there also, but first of all I'm going to connect the grounds. So this one is connected directly to this path, that gives a straight line connection, and the second pin of 7805 is definitely a ground, so I've connected it that there. And from here this is also connected to ground like this. Okay, yes. Oscilloscope, for that oscilloscope, yeah, that's a phone junction there. So of course that's a junction point. Instead of going that, I'm going to just directly connect it like this, or else, yeah, he has given us a direct connection. You can create it like this. Yeah, yeah, finally this one has to be connected here. And this part, for that part, what I'm going to do is I'm just going to reroute it like this. You can keep it here, or else, yeah, it's connecting to this one, right? Let me go a little bit higher, like there. Instead of going there, I will stop it here and make an angle from here, like this. Okay, I just want to keep this clear. That's it. It's no problem. I can directly connect from here also. That's not a big problem. Okay. See, if I connect it from there itself, if I connect it like this, what it's going to happen is in the 3D visualizer, definitely you are going to get the root. No problem, no doubt of that. But there is a chance that your marking that is here. So this will be erased. Okay, so there's a small chance of that. So just in order to keep that marking as it is, what I'm going to do is I'm just going to leave that part and I'm going to route it directly here, or I can do it like this also. Okay, to keep it clean. Okay, and the overlapping part, for this what I'm going to do is I'm just going to route my wire from here to this part like this. So go it. So he has given me the suggestions. Yeah, I'm going to keep it like this, and finally, not there, here. So this is the complete routing part. Now there is no overlaps here. You have to observe it. There are no overlaps here. And when you go for here, you will observe the routes like you have designed. If you observe that here, see it's going below this point. So yeah, it's going below the diode. So there is no overlapping. Okay. So this is okay. This is not problematic. I'm going to give the transformer inputs from here, okay, and from here this is going to be rectified, and from here it's going to the C2 along with the regulator output, and from here itself I'm going to take a point so that I can check the output, okay. Better we keep another point here for checking the output at the transformer, but that's completely your choice. And in order to reduce the board, what I'm going to do is I'm just going in the component mode and selecting the board, and I'm just going to resize this like this. I'm going to increase this so that I can place a uh, transformer here itself. I'm going to fix it with the screws, and by using jumper cables I'm going to keep it here, okay. Now, this is the complete virtual part of creating your PCB, your printed circuit board. This is not. There is one more final step, that is just creating the ready to print. What I'm going to do is I'm going to click here print output and print the layout. And here what I'm going to do is I'm going to keep it in PDF. Click on OK, and I'm going to uncheck all this. I don't need the bottom resist, top resist. I just need the top copper, top silk, and board edge. And I'm going to keep it 100%. So if I go for 150 or 200%, it is going to be zoomed in. Along with that, the points which are 100%, which at 100% are accurate, are going to be zoomed in. So instead of getting a zoomed in value, what I'm going to do is I'm just going for 100%, and I'm selecting OK. Finally, you will get a project. You will get a name. You will get the dialog box to save your PDF with. I'm going to save it with 7805 name itself. Okay. Yeah, that's it, and save it. Yeah, that's it. Now what I'm going to do is, yeah, this is our PCB layout. This is completely our PCB layout. If I zoom it here, you will get all the components. You will get all the necessary things that you need for placing your components onto the copper board and do the etching and all. Okay, so that's it, and hope I believe you get a clear understanding of how you do a PCB layout ready to print, and you might have get a clear idea. That's it for this video. Thank you.